Now we're going to look at division, and eventually we're going to get into some long division polynomial problems, and we're going to need to refresh our memories on the parts of a problem. So the answer is the quotient. What you're dividing by is the divisor. What is being divided would be the dividend, and then what's left over at the end is a remainder, and sometimes you get a remainder and sometimes you don't. Before we get to those, though, let's look at some simpler division problems. So here's just some monomial problems, and they look just a little bit more like fractions, and so we can treat them like fractions and just simply simplify. So with the top one, we have 30 over 5, which would simplify to 6, and there's nothing we can really do with that x to the 7th, so it's just going to hang out in our answer. On number 6, I like to think of these problems in chunks, and I would work with my numbers first. So negative 18 over 3 is negative 6. X to the 5th divided by x to the square, or x squared. Use your exponent rules. We would subtract our exponent, so it would be x cubed. So monomial times a monomial, you're really just simplifying each little part. Now on number 9, looks a little bit more complicated, but it's not too bad. What we have to do on these problems is take this x down here in the denominator and divide it into all the parts of the numerator. In other words, we actually have 3 little mini divisions inside this one problem. So if you want to rewrite it, you can as 13x to the 5th over x minus 16x to the 4th over x plus 20x squared over x. So this is actually what we're going to be doing math-wise. You don't have to rewrite it like this if you don't want to, but sometimes it just helps to visually see it. Now simplify each one of these individually. So 13x to the 5th over x would be 13x to the 4th minus, we have 16x to the 4th over x, that's going to be 16x to the 3rd, and 20x squared over x would be plus 20x. And all I'm doing there is using my exponent rules. If I have an x to the 5th on the top and an x to the 1 on the bottom, I subtract my exponents and got x to the 4th. Now I have another division problem, and we have the same situation, it's just written a little bit different. So this is the same thing as if I rewrote 60t to the 6th plus 36t to the 4th minus 18t squared divided by 6t. So you can rewrite it that way instead. Now if we just divide 6t into all 3, now instead of rewriting it, I'm just going to go through the math. 60t to the 6th divided by 6t. 60 divided by 6 is 10. T to the 6th divided by t to the 1 would be t to the 5th. Now let's move on to the next term. 36t to the 4th divided by 6t. 36 divided by 6 is 6. T to the 4 divided by t is t to the 3rd. Now we have minus 18t squared divided by 6t. Well, 18 divided by 6 is 3. T squared divided by t is t. So that's my final answer. Now we're going to look at dividing by polynomials, and this is where long division is going to come in. So the first thing I'm going to have to do is rewrite it as long division. So I'm going to have x squared plus, I need to leave myself a little bit of room, x squared plus 10x plus 25 divided by x plus 5. Later on you'll learn another method for dividing polynomials, but we're going to focus on long division. So the way that you start this off is we have x plus 5 as the divisor, and x squared is the first term of our dividend. So think to yourself, what times x gives me x squared? And the answer to that would be x. Oops. So x, and then I'm going to take this x and I'm going to multiply it by everything in the divisor. X times x is x squared. X times 5 is 5x. And then just like in long division, you would multiply it throughout, and then you would subtract that, which we're going to do here. Now x squared minus x squared cancels out, and that's what you want to happen. And then we'll have 10x minus 5x. And this is where you really have to watch your subtractions and your negatives. You can think of this as adding the opposite, which is how I'd like to think of it. And it's easier for you to see your x squareds drop out. They cancel each other out, and 10x minus 5x is 5x. And then you bring down the term you haven't used yet, plus 25, and you go through the entire cycle again. So this time you ask yourself, you've got 5x, so what times the x of the divisor would get you 5x? And that would be 5. And then you take that 5 and multiply it throughout. So you get 5x plus 25. You subtract that quantity. Remember, when you subtract, it's like adding the opposite. And then you can see the 5x minus 5x drops out, which is what you want. 25 minus 25, that actually also drops out, and you're left with a remainder of 0. So what's my answer to this problem? Well, my divisor is right here, and it is x plus 5. So the answer is x plus 5, and I have a remainder of 0, so I don't have to worry about that. So you're really just asking yourself a series of questions. Now let's look at this problem. This one's a little bit more involved. You're still going to want to rewrite it as a long division. There's a couple other things we have to do with this problem too. So let's get started. We have 4x to the 4th. And then we have a minus 5x squared. So it's like we missed or skipped over a cubed term if we're thinking in descending order. I like to go ahead and include that. So I would include a placeholder for that, and you'll see why in a minute. Minus 5x squared minus 8x plus 1. So it looks like we only had that one missing term, because now my exponents do go 4, 3, 2, 1, and then the number. Divided by 2x minus 3. So you want to think to yourself, remember we want the 4x to the 4th to drop out. So what can we multiply to make that happen? Well, I'm starting with a 2x, so I still need a 2x cubed. And I'm going to multiply that throughout. That's going to get me 4x to the 4th. 2x cubed times minus 3 would be a negative 6x cubed. Had I not put that placeholder in, I would not have had like terms line up like this, and that would have caused me issue. So now I subtract, so I'm going to add the opposite. And I see my 4x to the 4s, those drop out. 0x cubed plus 6x cubed is 6x cubed. Bring down my next term. Start the process all over again. This time we need to multiply to get 6x cubed. I'm starting with the 2x, so I think 3x squared will get that done. 3x squared times 2x, 6x cubed. 3x squared times negative 3 would be negative 9x squared. Subtract that. Add the opposite. And now I can see those drop out. I have a minus 5x squared and a plus 9x squared, which will give me 4x squared. Bring down the next term. Start all over again. So now I've got a 4x squared starting off with a 2x. So I need another 2x. And I'm going to multiply that throughout. So that's going to get me 4x squared. And 2x times minus 3 would be negative 6x. Subtract that whole quantity. Add the opposite. My 4x squareds drop out. Minus x plus 6x would be a minus 2x. Bring down my 1. Looks like I'm going to have one final multiplication and subtraction here. I have a minus 2x. I'm starting off with a positive 2x. So that's just going to be a multiplication of negative 1. Multiply that throughout. I'm going to get negative 2x plus 3 when I do that. Subtract the quantity. So add the opposite. My 2x's drop out. I have 1 minus 3, which is negative 2. So I have a remainder. So my final answer, my quotient, it's on the top row there, it's very colorful. 2x cubed plus 3x squared plus 2x minus 1. And the way that we can rewrite the remainder, there's a couple options. Depends on what my math lab asks for. But it may just have an r for remainder. And then you could just put negative 2. Or it may tack it on to the end of the polynomial answer in fraction form. So negative 2 over your divisor of 2x minus 3. So I had to kind of squish that in there. But that would be my final answer. So 2x cubed plus 3x squared plus 2x minus 1 was the main part of the quotient. And then my remainder was negative 2 over 2x minus 3. Recall, if you're dividing numbers and you wanted to write your remainder as a fraction, you would just take your remainder and put it over what you were dividing by. We did the same thing here.